Everyone say hi to Amy. Hi. Wish her well, right? Yeah. Okay, we don't doubt you anymore. All right, end behavior model. Here we go. The function, okay, the function g of x is, and then blank, blank, blank. Case number one is g of x is a right end behavior model, right end behavior model for the function f of x. Yes, that is right, f of x. If and only if, here we go, the limit as x approaches infinity of f of x divided by g of x equals to 1. Okay? I'm going to write down the definitions first, and then I want to talk to you guys about what it means in plain. So g of x, that g of x is the same as that g of x. G of x is the end behavior model. So number one happens to be the right end behavior model. Number two would be the left. So the function g of x is a left end behavior model for the function f of x if and only if the limit as x approaches negative infinity of f of x divided by g of x equals to 1. And again, the end behavior model is in the bottom. Now, number three, just purely vocabulary. If one function provides left and right side end behavior model, then it is called, we ignore the right and left, we just call it end behavior model. Okay, so what do I mean with all of those awesome fancy terms? Okay, so it says here the function g of x is the end behavior model. It can be right or left. Okay. If and only if. It's the right end behavior model if you take your function, which is f of x, and then you divide it by g of x, it equals to 1. So let me give you like an example. We're going to start with something really basic. Okay, so let's give ourselves f of x equals 3x to the 4th plus 1,000 x squared minus 99. Just for the fun of it. Here we go. Here's your f of x. I'm interested to know what the end behavior model is. Okay? Anybody remember what that means in Algebra 2 when you guys study this? What do you mean by end behavior model? Like, even just the terms itself, what does it mean? Yeah, right? End behavior, like, what does it look like at the end? Okay, so let me just kind of pinch this in and use decimals. A lot of it back then, you guys were using, like, let's use, like, okay, so something like this. 3x to the 4th, right, plus 100 or 1,000 or whatever value you want to add in there. An extra 0. Somewhere is my 0. There you go. Okay. You can add a 0 in there. You can add whatever you want. Okay, so here we go. If this is what I have on my decimals, I'm going to go back to zeros. When x is small, it will be significantly different between my blue and my red. Would you guys agree? if I can find it. Okay, see that right there? When x is small, the blue one is tiny, and then the red one is keep going on the bottom. Yes or no? Because it's a minus 980. But when x is large, okay, when x is super big, like in the thousands, okay, in the thousands and in the millions, guess what happens to the height? Would it get closer to each other as x gets bigger and bigger? Can you guys see that it's getting closer and closer as I move up? Right there, see you can still see the separation between the yellow and the red. I mean the red and the blue. But if I move up, I mean the x is getting big and bigger. Eventually, these two lines are actually the same. Okay, so that's what it means by end behavior. What is it going to look like in the end when x is so big? So this right here is actually the end behavior of that. But why? How come we can just use this to represent the end behavior of that? What's the logic? How come I can just ignore this thing right here altogether? How come those don't matter? Hmm?
That's just where it starts out. And then the graph eventually determined by the 3x to the 4, which is the highest
Degree? Right. So as x gets really, 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 really big, are these significant? Okay, they're not significant changes like Bill Gates and Jeff Bezos, right? They are so rich. They can give you a house in Huntington Beach and it wouldn't matter, right? Because they're so rich. That's what happened to those values, okay? So when you're looking at end behavior, you're looking at the power function, okay? So that's what it is. So let's go back to our example here. So if I said, okay, well, here's your f of x, what do you think the end behavior model is? What would g of x be, which is the end behavior model? It would be 3x to the 4th, okay? And here's what the definition said. It said, hey, if x approaches infinity or negative infinity, f of x divided by g of x, would it equal to 1? That's really the question. Okay. So if I take this right here, divided by that, would it equal to 1 as x gets really, 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 really big? Yes or no? Yeah, okay. Because these right here, are these significant when x is really big? No, okay. So that's what it means by end behavior model. Any questions on g of x, which is the end behavior model? All right, example 6. We're going to do an example 6. Example 6, we'll put more of that to practice. This is our last example of the day. For your function a and b, part A, find the power function end behavior model for f. That means you're looking for g of x. And B, find or identify any horizontal asymptote. For letter A, would you have any horizontal asymptote? No, right? Because it's not a rational function. So we can write B right away, no HA. Now for A, what's your end behavior model, which is g of x? What would that be? Negative 4x to the 3rd. Okay. That's it. It's that easy. Now, for the second half, f of x equals 3x squared minus x plus 5 all over x squared minus 4. Find the power function and behavior and find the horizontal asymptote. Do you guys remember how to find the horizontal asymptote from algebra 2? What do you do? Let's do that first since you know how to do that easily. How do you find the horizontal asymptote in algebra 2? Y equals what? Y equals what? How do you find the horizontal asymptote in algebra 2? If you know it, just let me know because I can't really hear you.
Y equals B.
Y equals B. I don't know what B is. You have to give me an actual value. Amy? No, that's a vertical asymptote. Good job, Amy. That's a vertical. That's the denominator equals to 0. That's your vertical. Horizontal asymptote. How'd you get it?
Because the order is the same, the largest order is the same, therefore it's just the numerator of the largest one.
Very good. Do you guys remember taking the power, the leading term on the top, divided by the leading term on the bottom? And then when you can reduce it. So Edison said this is actually y equal to 3. Okay, perfect. So that's the horizontal asymptote. It's algebra 2 skill. Okay, you don't have to. Okay, now find the power function, which is g of x, for f of x. What is your g of x? What must it be? So when I divide it by f of x, it's going to give me 1 as x approaches something ginormous, like a billion. So what would it have to be for it to be 1? Okay, so I'm looking for this. G of x equals to something. It's an answer. So this is true. Limit as x approaches infinity of f of x divided by g of x equals 1. That has to be true. So tell me, what is this blank space? X squared. Okay. Do you guys agree? Kind of close. You're closer. Let me ask you this. What's the leading term of this? Of f of x? 3x squared. Is this significant? Is this significant? Is this significant? So what's really significant for f of x? 3x squared over x squared, which is really? 3. Divided by something, so I can have 1. 3. Yeah, that's it. So guess what? This and that, they are actually the same. So in algebra 2, we call it horizontal asymptote. In calculus, it's called the end behavior. Okay? The higher the x go, the closer to 3 f of x will be.
The power function is the horizontal asymptote, or just in this case they're the same?
Power function and behavior model, they're actually the same. Power function it's in algebra 2, it's actually, this whole thing is 1. Power function and behavior. It's like, what's the biggest function that would describe the end behavior? Okay, so what's the function that describes the end behavior? David?
So the function is similar to f of x. Would their horizontal asymptote always equal their g of x?
If the degrees are the same, you're right.
Okay. But not if it's 3x cubed.
Then no. Then you have to do long division. That's an oblique asymptote. All right, that is an egg roll for today.
Is 3x